Am I audible on YouTube?
Am I audible on YouTube?
Can you hear me on Google Meet?
Yes, sir.
The problem yeah. So what I told is, if L dash is equal to, give a minute. If L dash is equal to L plus some function, can I say F? Function, okay, speak up. Then, if what he's saying is, this one of these quantities added to Lagrangian, okay. So, but equation of motion should not change, okay. Speak up. Then, if I write what you call this one, equation of motion for L dash, d by dt of dou L dash by dou x dot minus dou L dash by dou x equal to 0. Am I right? What is our old equation of motion? So that's why d by dt of dou L by dou x dot, okay, minus dou L by dou x equal to 0. Am I right? This is our old equation of motion. This is our new equation of motion, okay. So when they were to be equal, okay, when you just substitute this one, look at here, d by dt of, okay, dou by dou x dot of L plus f, am I right? Speak up. Minus dou by dou x of L plus f. Can I write like this? Equal to 0. Now, when I split this one, okay, d by dt of, what is this one? Dou L by dou x dot, okay, minus dou L by dou x plus, I'm just splitting this one. These derivatives are linear operator. You can always do like that, okay. Speak up. Plus, what is this one? D by dt of dou f by dou x dot minus dou f by dou x equal to 0. Fine. If these two were to be equal, then this portion must be 0. Keep volume bit low, okay. Isn't it? This portion must be 0. But while applying that one, you can observe that I think 3 and 4 options won't happen, okay. Speak up. It won't give you this part 0, okay. Speak up. Whatever you are adding, that function should again satisfy Lagrange's equation of motion, minus dou f by dou x equal to 0, okay. Speak up. So let us try with option first option may also not happen. Actually, I know that one, okay. That's why I'll try with second one. You have to start with first one, okay, while doing any trial and error, okay. So right now I will show that second option will satisfy, okay. Speak up. If you start doing that one, you will get to know quickly 3 and 4 are not feasible, but at least you should start with the first one, okay. Right now, to save the time, I'll show that 2 is the option, okay. So what is that? What was the option 2? xy double dot yx double dot, okay. F is equal to xy double dot minus y x double dot. Am I right? Here I wrote only one of the differential equation, okay, with respect to coordinate x. You have one more with respect to coordinate y, okay. Speak up. So now, what is this one? D by dt of, okay, dou by dou x dot of, what is this one? Xy double dot minus yx double dot, okay, minus dou by dou x of xy double dot minus yx double dot. Am I right? Speak up. This should be 0. So now let us see this one. But the main problem here is, what is the main problem? You don't have x dot here, am I right? To take x dot derivative. Okay, now I'll change the order of the derivative here. Speak up. Dou by dou x dot of, okay, I will take the time derivative of xy double dot minus yx double dot. Now, so can you get me the proof for this one? Okay, I think you said what is that? Where Sham series book. So something is there. Am I right regarding this one? Okay, that we can change the order of the derivative. Okay, speak up. What is this one? This is simply y double dot. Am I right? Isn't it? Partial derivative with respect to x minus y double dot. Okay, so this will be dou by dou x dot of. Okay, if you take the derivative, what will happen? X dot y double dot as it is. Okay, so plus x as it is, y triple dot. I don't need the rest of the part actually. Minus y dot x double dot minus y x triple dot. Because when you take partial derivative with respect to x dot, only one will remain here. Okay, speak up y double dot. Okay, check this out. This will be y double dot minus y double dot. That's equal to 0. And check the same thing for what is that? If it is y dot, I mean, if you wrote the equation, okay, for y, I mean, it's a 2 degree of freedom problem, am I right? Speak up. He gave like that. Okay, I mean, but I mean, this is sufficient to eliminate option. Fine. I mean, the only tricky part is this one. Okay, speak up. Interchanging this one, because you have second derivative, you don't have first derivative directly to take partial derivative with respect to x dot here. Fine. Speak up. And if it has y dot, yeah, then also the same thing will happen. Okay, here some opposite sign will come. Okay, it will again get cancelled. Okay, I wrote the equation for one of the generalized coordinate and I proved that that is the right option. Okay, so I mean, others won't be feasible. Okay, speak up. Option 2 is the feasible one. Okay, speak up. Now let us move on to central force problem. Okay, speak up. When you see the questions, I think at the end you may able to speak up. Differential equation of orbit. Do you remember? A particle r as a function of theta is given. A particle in 2 dimension found to trace an orbit r of theta, that's equal to, speak up, r naught into theta square. Okay, if it is moving under the influence of a central potential v of r, that's equal to c1 r power minus a plus c2 r power minus b. Okay, so c1 c2 are constants, okay, of appropriate dimension, value of a and b respectively. R as a function of theta is given. What you have to find? You have to find force law from that potential. Okay, speak up. Can you recall the differential equation of orbit? We define something u which is equal to 1 by r. Am I right? Then d square u by d theta square plus u equal to minus m by l square. U square or 1 by u square? Okay, you write d by, can I write d by d theta of, or d by du of 1 v, or I mean, okay, what is this one? I mean, here 1 by u square into f, f of 1 by r. Am I right? 1 by u, sorry, f of 1 by u. Okay, f of r, f of 1 by u. Okay, that means that is f of r. From that f of r, you can find v of r. Okay, if you find f of r, is that okay? Speak up. Now, what should I do? So 1 by r is nothing but 1 by r naught into 1 by theta square. Am I right? Speak up. What is du by d theta? That's equal to minus 2 by r naught into 1 by theta cube. Fine. 1 by theta square. Speak up. D square u by d theta square. What is this one? Minus 2 minus 3. 6 by r naught 1 by theta raised to 4. Is that right? Speak up. Then just we need to substitute. Am I right? 6 by r naught. Okay. 1 by theta raised to 4 plus u. What is this one? 1 by r naught into 1 by theta square. That's equal to minus m by L square 1 by u square f of 1 by u. Okay. That means u square is multiplied to the left side, isn't it? What is u square? 1 by r naught square into 1 by theta square, isn't it? So, huh? This u square to be taken this side, am I right? Or actually, what I'm thinking is, okay, this can be written in terms of potential directly. I wrote that expression. D by du of v of 1 by u. Will that help, or you prefer finding force and then go to potential? Because he's asking potential, am I right? Speak up. Anyway, let us do, because you may not able to remember many formulas, 1 by u square f of 1 by u. Okay, speak up. So use, okay, can you write these things in terms of u? Which one? 1 by u square. Can you write these things in terms of u? That's better. What is this one? 1 by r naught theta square. Am I right? Speak up. I'll do one thing. So 6 r naught. Okay. 1 by r naught square. R naught into, sorry, yeah, r naught theta square the whole square. Can I write like this? Just manipulating. Okay. Plus 1 by r naught theta square. That's equal to minus m by l square 1 by u square f of 1 by u. Okay. So what is this one? Into u square plus this is u simply. So that's equal to minus m by l square 1 by u square f of 1 by u. Okay. So then when you multiply f of 1 by u, that's equal to minus l square by m times, okay, u square multiplied. Okay, that's why 6 r naught into u raised to 4 plus u raised to 3. Am I right? Be careful, this is force, not potential. Okay, speak up. So that's why if you write f of r, what would you get? So minus l square by m. Okay, what is this one? 6 r naught by r raised to 4 plus 1 by r raised to 3. Am I right? Speak up. But this is equal to minus dou v by dou r. Force is equal to derivative of potential. Now, how do you find v? Just integrate it. Speak up. Don't worry about any constant. Okay. Speak up. So if you integrate it, what would you get? V of r, that's equal to. I'm not worried about that constants here. Okay. L square by m. Okay. So 6 r naught integral of 1 by r raised to 4 dr. Okay. Plus integral of 1 by r cube dr. Fine. What is this one? What is this one? Minus 4 plus 1, 1 by r cube. I don't need any constant actually. Okay, 1 by r cube will come. Okay, what will happen? Plus something into 1 by r square will come, isn't it? That is the only thing that I need to answer the question, isn't it? R raised to minus 4 plus 1. Okay, r raised to minus 3 plus 1 after integrating. Okay, so that's why that 3, what is that? Minus 3 minus 2. Am I right? Speak up. When you write the potential, minus 3 minus 2. Okay, minus 3 minus 2. He already wrote minus. Okay, a equal to 3, b equal to 2. Speak up. 2 and 3 he might have interchanged. Okay, that doesn't matter. Is that okay? Speak up. One of that one is 2, other one is 3. Okay, fine. Option 2, differential equation of orbit. I don't think there is any other way. You need to remember the this differential equation. Okay, what is that? Differential equation of orbit. Okay, I think we solved a couple of problem on this one. Okay, check this out. Okay, neatly do this one. Okay, I think I did some more step extra. Okay, speak up. Check it can be minimized. Fine, speak up. So a satellite of mass m around Earth in elliptic trajectory of semi-major axis A at a radial distance r equal to r naught measured from the center of the Earth, kinetic energy equal to half the magnitude of the total energy. Okay, speaker. If m denotes the mass of the Earth and total energies, m denotes the mass of the Earth. Total energy is Gmm by 2a. Usually capital M we take for sun mass. Am I right? Anyway, speaker. Yeah. So that doesn't matter. Okay. It is. It is moving in one elliptic orbit. Okay. Speak up. This is the sun. So this is at sun. You can think like this. Okay. Okay. Sorry. Satellite. He took satellite. Am I right? Speak up. Satellite of mass m. Okay. Earth of mass capital M. Yeah. This idea is right. Okay. I was thinking Earth. Earth is heavy mass, satellite is small mass. Okay. So somewhere here. Okay. Somewhere at one point. Okay. Speak up. What he's saying? It's kinetic energy at one point r naught. Okay. What is this one? This is Earth, this is satellite. Okay, satellite is moving in one elliptic trajectory of semi-major axis A. Okay, so at radial distance r equal to r naught. Okay, kinetic energy is equal to, speak up, half the magnitude of energy. Energy will be negative for elliptic orbit. Okay, bound orbit. Am I right? Energy is negative actually, but he said kinetic energy is equal to half the magnitude of the total energy. Okay, this is one equation he gave. Okay, then other equation what he gave, energy itself equal to minus Gmm by 2a. I think this one we proved actually. Am I right? Speaker, for elliptic orbit. I think we had k here, isn't it? K by 2a or something. Okay, a is a semi-major axis. Okay, speaker. Then the value of r naught by a is nearest to. Okay, speaker. So now look at here, this total energy that's equal to kinetic energy plus potential energy, V of R. What is that V of R usually? By just seeing this one, you can, satellite and Earth inverse square law. Okay, you can quickly say, what is this one? Minus Gmm by R. Am I right? That is your potential. Okay, speak up. At R equal to R naught, you know what is the potential V at R naught? What is this one? Minus Gmm by R naught. Okay, you just substitute that one. Okay, he's asking. Okay, so E is equal to kinetic energy when R equal to R naught, isn't it? kinetic energy when r equal to r naught plus v at r naught. Okay, so what he said, kinetic energy at r equal to r naught. Okay, so minus gm m by 2a. What he said, this is half of magnitude of the energy. Okay, that's equal to gm m by 2a. Okay, mod of energy. Okay, pick up minus potential energy g m by r naught. Okay, kinetic energy when r equal to r naught, that's equal to half of magnitude of the energy. Okay, speak up. You just solve it for r naught. I mean, nothing. I mean, you just have to write this equation, and you have to think. Okay, so not much big deal. Fine. Speak up. Can you solve it? So I'll take it here. That's equal to by 4a plus gmm by 2a, isn't it? 1 by r naught, that's equal to 1 by a times 1 4 plus 1 by 2. What if 1 by 4 plus 1 by 2? Speak up. 3 by 3 by 4. Okay, so that's why what he's asking, r naught by a. So r naught by a, that's equal to 4 by 3. What is 4 by 3? 1.33. Speak up. 1.33. Fine. I don't think any difficulty is there. Okay, speak up. Start writing the equation, you will get idea. Am I right? I just wrote given. Okay, these two are given quantities, isn't it? I mean, I just draw this one for my convenience. Okay, I mean, anyway, that this diagram is not helping. Okay, speak up. So then he's asking us to connect it to radial distance. Potential depends on radial distance. Okay, that's how I quickly connected. Okay, remember whatever speed comes here in kinetic energy, that contain both radial as well as tangential speed actually. Okay, speak up. They both contributing. Okay, when we write this expression. Okay, speak up. So do you remember we used to write one more expression, V effective? There kinetic energy part contain only half m r dot square actually. Okay, so here r dot square as well as r square theta dot square both will come. Okay, anyway, so I mean, we don't need that one. I mean, this is very simple problem. Okay, but you should know that one. Okay, you should have that clarity. Do you remember? So half m r dot square plus V effective of R, this is equal to total energy that is conserved. Am I right? Do you remember what is this V effective? I mean, equivalent one dimensional problem or something. Okay, we discussed like that. That's equal to V of R 2m. Sure. Huh. This is helpful in other problem. Okay, speak up. So I mean, this is when you write only in terms of radial distance. Okay, so but actually what you call your kinetic energy, half m r dot square plus r square theta dot square. Okay, plus potential energy V of R, that's equal to E. Then we had one conserved quantity. What is this one? M r square theta dot, that's equal to L. Am I right? So from this one, okay, we enter to this one where V effective is this one. Okay, we avoided theta dot using this equation. That's it. Okay, speak up. A particle moves in three-dimensional space in the central potential k r raised to 4, where k is a constant. The angular frequency omega for a circular orbit depends on the radius r. What is the circular orbit condition? Okay, speak up. For circular orbit, we wrote one equation, f of r naught is equal to minus mv square by r naught. R naught is the radius of the circle, but he took capital R over there. Okay, radius is so capital R. Okay, speak up. First, we need to find f of r. What is f of r? Minus dou v by dou r. Actually, it's a negative gradient, but it depends only on one coordinate. Am I right? Speak up. What is this one? Minus 4k r cube. Okay, f of r is minus 4k r cube. Okay, so that means f of capital R is the radius of the circle, that's equal to minus mv square by capital R. Can I write like this? So what is this one? Minus 4k r cube, that's equal to minus mv square by r. Okay, that means r is to 4, that's equal to m by k into v square. Can I keep it one side? R and v relation we got. Fine. R is to 4, m by k, v square. Negative sign got cancelled. Okay. Then what is asking? I mean, if it is a purely circular orbit, okay, speak up, with the radius equal to suppose r, it will move with a uniform speed. Am I right? Pick up. It will move with a uniform that tangential speed v actually. Okay, so that's why you can write time period is equal to 2 pi r divided by speed is equal to 2 pi r divided by it's a uniform circular motion. Am I right? Speak up. When it has, I mean, a circular motion is uniform actually. Okay, your v will be constant. I mean, not velocity. Okay, speed will be constant. Okay, that's why that speed can be written as 2 pi r divided by time that it takes to trace 2 pi r. Am I right? So that's why time period that's equal to 2 pi. What is this one? R by v. What I need here? I need to substitute for v. V is proportional to r square, isn't it? V is proportional to r square. Anything missing here? Okay, he's asking frequency, am I right? Not time period. Yeah, I mean, so this is right. Okay, so frequency is nothing but 2 pi by t. 2 pi by t itself is angular frequency. Okay, what is 2 pi by t? That's equal to v by r actually. Okay, v is proportional to r square. Okay, since v is proportional to r square, omega proportional to r. Fine, very simple. Any question? Fine. And one more question, I hope you can take care. Okay, what is that? The same question. Circular orbit, okay, in a central force. Okay, n is between 0 to 2, he mentioned like that. Okay, where k is 0. If the time period of the circular orbit of radius r is t1 and radius 2r is t2, then t2 by t1 is. Speak up. What to do? First find f of r. What is this one? Minus dou v by dou r. What is this one? Minus, okay, k r power minus 1. Okay, k r power minus n. Okay, what is the derivative? Minus n r power minus n, minus n minus 1. Am I right? Speak up. That is f of r. Then circular orbit condition. What is this one? F of r, that's equal to minus m v square by r. So okay. Any mistakes? No, it's a derivative. Hmm? K is greater than 0. Huh. Force should be attractive, am I right? That's what I'm thinking.
That minus only one minus sign will complete second step.
Second step only one minus. Okay, minus dou v by dou r. This minus sign I carried out. One more minus sign is there in the potential. Hmm? One more minus sign because of derivative. Okay, I mean, look at here. I mean, that's that physical aspect I was keeping in my mind. What is that? It should be attractive, am I right? When force was positive, I was a bit worried. Okay, so that's why that's equal to minus kn into 1 by r power n plus 1. Okay, fine. So now, I mean, sorry, f of r here, f of r here. Okay, so that f of capital R for a circular orbit minus m v square by capital R, isn't it? So that's equal to kn divided by r power n plus 1. That's equal to m v square divided by r. Okay, you can see here one of the r you can cancel out. Okay, speak up. Kn divided by r power n, that's equal to mv square. Am I right? R power n I into r. Okay, one of the r I will get, I will cancel it out. Okay, speak up. Then, I mean, what I got here, v square proportional to 1 by r power n. Am I right? Speak up. V square proportional to 1 by r power n. Then, what is that? I mean, since again it's a circular orbit, okay, so radius r, speed v, that speed v can be written as 2 pi r divided by time period. Time period is equal to, I mean, 2 pi capital R. Okay, speak up. So time period is equal to 2 pi r by v, isn't it? So you just work out proportionality here. Okay, r by v. Okay, speak up. V is proportional. Sorry, v square proportional to 1 by r power n. V proportional to 1 by r power n by 2. Speak up. So that's why. So T is proportional to R by R power n by 2. Am I right? Which is equal to R power 1 minus n by 2. What is this one? R power 2 minus n by 2, isn't it? Let me know if any mistakes. Okay, speak up. Then what is said? T1 is for, I mean, so let me say this is T1. Okay, T2 proportional to 2R power 2 minus n divided by n by 2. Okay, he's asking T2 by T1, isn't it? For capital R radius, this is the time period proportionality. Okay, for 2R radius, this is the proportionality. Okay, speak of both are circular orbit. Okay, he mentioned like this. So T2 by T1, T2 by T1, that's equal to 2 power 2 minus n by 2. I mean, you have option. T2 by T1. Any mistakes? Quickly, any mistake? Huh? What happened? No, no. V was proportional to inverse of that one. Am I right? Yeah. I mean, yes. I mean, you should write. You should not write directly. V was proportional to 1 by r power n by 2, isn't it? Then substitute. T will be proportional to, okay. So r multiplied with, okay, 1 by v. That means r power r divided by, speak up, 1 by r power n by 2. isn't it? V was proportional to 1 by r power n by 2. So that's why it is equal to r power 1 plus n by 2. Fine. 1 plus n by 2. Okay, speak up. Suppose if I take this one as T1, then T2 proportional to 2r power 1 plus n by 2. Okay, speak up. What is this one? T2 by T1, 2 power 1 plus n by 2. You have that option. Okay, speak up. 1 plus n by 2. Okay, speak up. I mean, what is the algorithm here? Your this equation, okay, this is the equation for, I mean, force, okay, that's equal to minus mv square by r. Okay, that is the main equation. Okay, that will help you to find the relation between speed and radius, isn't it? And he's connecting it to, in the earlier problem, what is that? He's connecting it to angular frequency, in this problem time period. Okay, speak up. Have habit of writing the detailed step. Okay, then mistakes won't happen. Okay, if I skip any step, usually mistakes will happen. Virial theorem is another frequent question in exams. Okay, all exams. Okay, consider a set of particles which interacted by a pair potential. Okay, V is equal to V of r is equal to a r power 6 here. Okay, where r is interparticle separation, a is greater than 0, is a constant. If a system of such particle has reached virial equilibrium, speak up, the ratio of kinetic energy to the total energy of the system is, speak up. Now, what is that virial theorem expression? Can you recall? Average kinetic energy, that's equal to, I mean, no, some negative sign won't come. Del v dot r cap or r minus 1 by 2 gradient of, I mean, gradient of v, dot product with r or r cap. You should remember that one. Okay, speak up. I mean, I'm expecting you to remember very less expressions. Okay, speak up. In whole central force, I mean, no negative sign. No negative sign. Speak up. Average kinetic energy, that's equal to, fine, half of average of gradient of v dot r vector, not r cap. Check this out. So this will relate kinetic energy to potential energy, but what you have to do, you have to relate kinetic energy to, so total energy. Am I right? So total energy, that's equal to kinetic energy plus potential energy, isn't it? Speak up. Just find this relation first. Okay, using virial theorem. Okay, speak up. What is this one? Half of. Okay, what is gradient of this one? That's nothing but only radial part is there. Am I right? So that's why that is dou v by dou r into r cap. Do you remember? In spherical polar coordinate, writing gradient operator. Dou by dou r into r cap, then dou, I mean, so r, I mean, so theta cap by r will come into dou by dou theta, dou by dou phi. That dou by dou theta, dou by dou phi is 0. Why? This doesn't depend on theta or phi, isn't it? So what is this one? This is nothing but 6a r raised to phi r cap. Okay, so that's why this is equal to 6a r raised to phi r cap. Okay, dot product with r into r cap. Can I write r vector like this? Speak up. So here You try to write this one in terms of potential again. Now, what happens is you took derivative, again you multiplied, am I right? Multiplied by r, isn't it? So that's why it can be again written in terms of, because derivative will decrease 1 power, multiplication it again increases 1 power. The whole thing can be written in terms of potential again. Okay, speak about this one. So 6a r raised to 6. Okay, this is nothing but, so a r raised to 6 is 6 by 2, that is 3. 3 into, this is v. Fine. Now what is asking? Kinetic energy to total energy. Okay, speak up. Now I will come to this expression, kinetic energy. I'll write potential energy in terms of kinetic energy. What is potential energy in terms of kinetic energy? 1/3 of kinetic energy. Am I right? Speak up. Hmm? Any question? What is asking? Kinetic energy to energy. Am I right? That's equal to 3 by 4. Fine. I found this question is bit frequent. Okay, I mean all exam together. Okay, speak up. Here and there I found this question. In just exam also I found 2 to 3 questions. Okay, can you do it? This expression must be remembered. Hmm. I mean, yeah. In Ghostin, he made one generalized formula. Am I right? Now, so they are aware that we may by heart the formula and exhibit. Okay. In one of the just exam, what he did is he gave v in a Cartesian coordinate. Some x square y cube, like that. I think you might have seen that question. Okay, then you need to apply this one. Okay, it won't be that time consuming. Okay, I mean, if it is too lengthy, then I will suggest you to somehow remember some technique. Okay, I mean, what he's saying is, for a general potential r power n or something, okay, you can remember one relation between t and v. Am I right? That will save the time. But they may manipulate the question like this: what if v is given in Cartesian coordinate and they expect the similar thing? Then you need to find this gradient and proceed. Okay, be careful in that one. Fine. 3 by 4. So should I check answer key? I mean, you should be confident at your method, so that method and steps. Okay, you don't have to check the answer key. Okay, speak up. So this problem you should answer without solving, just by logical idea. For a particle moving in a repulsive central potential, O is the center of the potential. So V of R, that's equal to A by R. Okay, F of R, that's equal to minus dou V by dou R. What is this one? A by R square. Am I right? Repulsive central potential. Okay, which of the following is the best suitable trajectory? Speak up. Can you tell me? That means whatever trajectory that you are shooting, okay, it is getting repelled by that center of the force, isn't it? So then, if it is repulsive, okay, circular, or I mean, this kind of orbit won't happen. Am I right? Circular orbit won't happen. You need attractive force for circular or what you call elliptic orbit. Okay, that quickly removes two of the option. You see other two option. Okay, here you have the particle, so trajectory. Here you have the center of the force. It bent towards the center of the force. Am I right? That can happen only when it is attractive, isn't it? But in this case, so this is the particle. Okay, you have shooted here, isn't it? And it is getting repelled by the center. It is getting repelled by the center. What is the best example, realistic example? Rutherford scattering. Inverse square law only. Okay, alpha particle and gold nucleus. Okay, both are positively charged. Okay, repulsive force. Fine. Speak up. Logically, you can answer the question because, I mean, other three option can happen only for attractive force. Okay, elliptic and circular orbit. Okay, and this also it bent towards the center of the force. Okay, speak up. If this is repelling, why it would bend towards? Am I right? It should go away from this one, isn't it? Like that, you can answer the question. Fine. Very logical question. Okay, no mathematics is required here. Okay, speak up. Maybe parabolic or hyperbolic trajectory, isn't it? Fine. Quickly. So a particle of mass m moves in a central potential v of r is equal to minus k by r in an elliptic orbit. Okay. Usual Kepler problem. Okay, speak up. Where r of theta is given. Okay, that's equal to, speak up, a into 1 minus e square whole divided by 1 plus e cos theta, isn't it? Speak up. Where theta is between 0 to 2 pi and AE denotes the semi-major axis eccentricity respectively. Okay, we know this one, am I right? I mean, we wrote, actually we used to write R is equal to C by 1 plus E cos theta or something. Then we connected, okay? Check that out, okay? So in the class, we wrote this expression, okay? Anyway, that doesn't matter. Whatever he gave, you should be able to get the answer, okay? I mean, you don't have to look into your expressions, okay? If the total energy, okay, that's equal to minus k by 2a, okay, the maximum kinetic energy is, speak up. So energy is equal to, again, I'll try to make it like this: kinetic energy plus potential energy. Am I right? Speak up. That kinetic energy, that's equal to, energy is minus k by 2a. Okay. I mean, what is this V of r? Minus k by r. Okay. So kinetic energy minus k by r. So minus k by 2a. Kinetic energy, that's equal to minus k by 2a plus k by r. Okay. When this kinetic energy will be maximum? When this, this one you can't change. Am I right? When this is maximum, this additive part, isn't it? Minus k by 2a plus k by r minimum. When r equal to r minimum, isn't it? K by r minimum. This have the maximum value. Can you see this one? Speak up. That means, even logically also you can say, am I right? That aerial velocity must be constant. Aerial velocity of a radial vector must be constant. Okay, nearby this one, it will be moving with a high speed actually. Okay, when r is equal to r minimum. Okay, so when it is further away, it is moving with a low speed actually. Okay, speak up. To keep, what is that, radial velocity, aerial velocity of a radial vector. Am I right? Area swept by radial vector per time. Okay, that should be constant. Kepler, which law? Second law. Okay, speak up. So that's why, when it is at the nearest, distance from the center of the force, okay, you will have the maximum kinetic energy. That's what it is saying. Okay. Now, when that will happen, when this R minimum will happen, when theta equal to, you can see here, when theta equal to 0. When theta equal to 180 degree, you have lower denominator. Am I right? R will be higher, isn't it? Speak up. So that can happen when theta equal to 0. You can see here, when theta equal to 0. Fine. So that's why R minimum, you got the expression. What is that? R minimum is equal to, wait a second, I'll write R one more time. What is R? A into, speak up, A into 1 minus e square divided by 1 plus e cos theta. Okay, speak up. R minimum will happen when denominator is maximum. When denominator will be maximum? When theta equal to 0. Okay, speak up. That a into 1 minus e square divided by 1 plus e cos 0 degree. Okay, that's equal to a into 1 minus e square divided by 1 plus e. That numerator can be written as 1 plus e into 1 minus e divided by 1 plus e. That's equal to a into 1 minus e. Okay, that's your R minimum. Okay, let me substitute this one. Minus k by 2a plus k by, speak up, what is R minimum? A into 1 minus e. Fine. But he's writing in terms of energy. Can you see? His answers are in terms of energy. Then what you do? You should try to write that expression in terms of minus k by 2a. Isn't it? What should I do? You take minus k by 2a outside. That's your energy. Okay, speak up. That's equal to 1 minus, I think, 2 divided by 1 minus e. Check this up. Will this work? Minus k by 2a. Okay, speak up. Then this is nothing but your energy, which is negative. Okay, so 1 minus e minus 2 divided by 1 minus e, isn't it? That's equal to e into minus e minus 1 divided by 1 minus e. So if you absorb negative sign, okay, so e plus 1 divided by e minus 1. Fine. E plus 1 divided by e minus 1. Yeah, you have the option. Again, what I'm thinking, again, you should be just keep on writing the expression and connect them. Not much big deal. So shall I proceed? Yeah. Good. I'll move a bit faster tomorrow. Okay, you guys just work on the rest of the problem. Let me just try to give the hint for this one. Okay. Assume that Earth revolves in a circular orbit around the Sun. Suppose the gravitational constant g varies slowly as a function of time. In particular, it decreases to half of its initial value in the course of million years. Then during this time, the radius of the Earth, total energy, orbital angular momentum, okay, radius of the Earth orbit, radius of the Earth orbit remains the same. Yeah, which one of the following option? Now you should connect it to equations only. Okay, I mean, when you have pure question like this, okay, you have to connect it to equation, then only you can strongly argue. Okay, speak up. Write down circular orbit all equations. Okay, speak up. So one is that mv square by r naught, force equal to mv square by r naught. Am I right? F of r naught, that's equal to minus mv square by r naught. Speak up. So this is nothing but minus gm m by, that's equal to m minus mv square by r naught. Okay, speak up. This is one expression. Is that right? Force. Speak up. G m by r naught. Only one r naught will remain. That's equal to mv square. That's one thing. Then I mean, if you take a sun, actually, I mean, you don't have to, I mean, that reduced mass concept can be taken. Okay, anyway. So suppose, what is your angular momentum? Oh, angular momentum is also simple. MV R naught, isn't it? Angular momentum is also simple. MV R naught. What else you can connect? Quickly, try to eliminate option. Think with me. Energy is equal to energy is equal to now I'm thinking this particular curve, whatever we used to draw, okay, we are not utilizing that one. Okay, speak up. Circular orbit will happen when energy equal to this value, isn't it? So check this out. I mean, this may help actually. Okay, that curve. Okay, V effective. Can you recall? We have drawn V effective as a function of R. Okay, for attractive inverse square force. Okay. Now what I'm saying is, okay, when you change that G, okay, that V effective. What was V effective formula? Minus K by R. V of R, that is minus G M by R plus L square by 2m R square. How do you connect the equations? Think over it. Okay. Think. You have to.
Is 1 by half of that.
Hmm?
That G is half.
Hmm.
Then R naught should be decreased.
What about V? Hmm? You don't have only R naught here. V square into R naught. Am I right? Speak up. So think over it. Okay. I'll come out with my idea. So this curve will change. Okay. Speak up. This curve will change. So when this G changes, this curve will change. Okay. Speak up. And what we need to do is, okay, we need to conserve angular momentum. I feel like that. Okay, because when I solved other books problem, okay, they used to conserve angular momentum. Okay, I mean there are some just problem also. Check this out. Okay, one I mean it will go from one orbit to other orbit. Okay, keeping the same angular momentum and all. Okay, speak up. So then what I'm going to do here is, okay, so GMM, okay, this expression, okay, I'll write M V R naught the square divided by R naught, multiplied and divided by R naught. Now what would happen? I mean, this is constant now, isn't it? Numerator is constant now, divided by R naught. Now what would happen? G is, what is it? It decreases half of its initial value. Then R naught will be, speak up. No, I mean, if G becomes, I mean, G is proportional to 1 by R naught, isn't it? I mean, by conserving angular momentum, I wrote that expression. Okay, speak up. So, but how to grab this idea that angular momentum is conserved in the process? Let me think over it. Okay, if I have conservation of angular momentum, so when the g becomes half means r becomes double. R becomes double of the earlier one. Okay, speak up. Radius of the Earth orbit will increase by a factor 2. Speak up. So this is wrong. I mean, that's what I took. Angular momentum of the Earth will increase. I mean, I took angular momentum is conserved. Okay, in the process. Fine. I mean, only one option. I mean, CSIR net question. You know that you have only one option. Okay, so that's why you can proceed. Fine. So check this out. By conserving angular momentum, I'll just rub out this one. Okay. Speak up. I have rewritten this one because here I have V into R naught. Am I right? I need that V into R naught, multiply and divide by R naught, V R naught the square by R naught. Okay. So that I can relate them. Fine. Speak up. Yeah, so you guys try the rest of the thing. Okay, I'll keep in the slide. Okay, speak up. Now look at here. This is last December CSIR net question. Okay, so he has given a potential. Okay, speak up. The necessary condition to have a stable circular orbit. What would you do? You have to find V effective. That V effective must have minimum for stable circular orbit. Okay, they asked two central force problem question. Okay, speak up. In last December, I hope last December. Yeah, last December only. December 23, isn't it? What is other question? A particle of mass m is moving in a stable circular orbit of radius r naught with angular momentum L for a potential V of r is equal to B r power k. Okay, which of the following is correct? He said, what is that? Stable circular orbit. The stable circular orbit, okay, that can happen only for Hooke's law and inverse square law. We have seen that one, am I right? Pick up. So that's why, I mean, I think I can quickly say, I mean, k is equal to 2, am I right? I mean, he wrote V of r is equal to beta r power k, isn't it? Half k r square, Hooke's law. I mean, that's why I'll quickly eliminate these two. What do you say? And in other two, you need to work on. Is that okay? You take again circular orbit condition related to angular momentum. Relate that one to angular momentum. What is f of r? That's equal to minus k beta r power k minus 1. Okay. F of r naught is equal to minus mv square by r naught. Angular momentum is equal to mv r naught. Am I right? Circular orbit mv r naught. Remember, while writing that angular momentum, actual angular momentum was m. Do you remember? M r square theta dot. Angular momentum conservation. I wrote some expression somewhere here quickly. M r square theta dot was angular momentum, right? Speak up. So, but what will happen here is, okay, m, I mean, in case of circular orbit, can I write m r into r theta dot? In case of circular orbit, what is this one? This is your v theta. I mean, if you write your v as vr r cap plus v theta theta cap, okay, r dot r cap plus r theta dot theta cap. In circular orbit, there is no r dot. Okay, only r theta dot. Am I right? That's why for circular orbit, this is v. That's how mvr equal to L. Don't write that the same thing for your elliptic orbit. Okay, speak up. Both Vr and V theta will be there. Okay, but mr square theta, mr into this expression is actually mr into V theta is equal to L. Be careful. Fine, speak up. Now, now I think, I mean, you guys try that one. Okay, I gave enough hint here. Okay, speak up. So in the last question, did he mention angular momentum conserved in this question? Did he mention anywhere? No, I mean, anyway, one of the option, he changed the angular momentum. Okay, speak up. But how do you get that idea that angular momentum must be conserved? Let me try to argue in the next class. Okay, in this one. So how I got it? I mean, there were some Ghostin and just problem where they have done some changes, but they kept angular momentum same actually. Okay, out of that idea, I just applied. Okay, but I'll get it from books. Okay, speak up. Fine. You just substitute and you just what you call write this R naught in terms of angular momentum L. I mean, he took capital L. Okay, speak up, because V into R naught you can write here L by M, isn't it? Substitute and proceed. What is f of minus k beta R naught power k minus 1, that's equal to minus m v square into R naught power minus 1. Am I right? Speak up. That R naught power minus 1 will get cancelled. So what you do? M v square. Okay, k we have already chosen as 2. Am I right? K we have already chosen as 2. If k is 2, okay, then what I need is I need R naught square here. Okay, to write in terms of angular momentum. I mean, I'm manipulating myself, okay, into R naught square here. Okay, I just multiplied both sides with R naught square. Okay, so that here M R V R naught the speak up whole square. Okay, K beta R naught raised to 4. What is this one? M L square by M square. K beta R naught raised to 4. What is this one? R naught is equal to L square divided by M K beta raised to 1 by 4. And where is the mistake? That K I didn't substitute. K equal to 2. K equal to 2. Okay, can you do this one? Okay, can you do this one? K equal to 2 here. Fine. K equal to 2. Yeah. I think only one more problem exists. Okay, I will pick it tomorrow. Speaker. When you see overall again, keep writing the expression again. Am I right? Some are quite conceptual. Okay, speak up. Most of them are keep writing the expression. Okay. Now, what one doubt which is remained? Speak up. How I took angular momentum conservation. Okay, in this particular problem, even though that what is that gravitational constant is changing. Okay, so what is the key concept behind this one? Okay, speak up. By taking angular momentum conservation. Okay, so that is the only thing left in this one. Fine. Speak up. Any question? Okay, tomorrow I will move on to that drawing phase space trajectory. We have very many questions. Okay, in CSIR net. Okay, So I'll pick that one. Okay, along with one more question is there somewhere. Okay, on central force. Okay, uh, yeah, you have to do along with this. You have to do that Lissaj's pattern also. Okay, Hooke's law force in case of two dimension. Okay, speaker in this one. Hmm? Yeah. So now tomorrow I'll pick phase space trajectory question, okay, and some Hamiltonian dynamics related question, okay. So then, I mean, we shall spend one more day on canonical transformation because that question is very frequent in CSIR net, okay, speaker. So then we will move on to mathematical physics, fine? Yeah. Okay, we'll meet tomorrow.